Now we'll move to the next chapter, that is the next part of the drugs acting on cardiovascular system, and that is vasodilator and or sympatholotics. Okay, as the name indicates, there are two different parts. That is, the vasodilator is different, sympatholotic is different. Okay, so the vasodilator, they are responsible for the directly dilating the vessels. Sympatholotics, they are also responsible for the dilatation of vessels, but they are indirectly acting on the vessels so that the blood vessels or the vessels can be dilated. Okay, so as the name indicates, vasodilators, it is divided into two parts, that is the vaso and dilators. So vaso means vessels, dilator means which can dilate the vessels. Okay, so the drugs which are responsible for the dilation of the vessels, they are called as vasodilators. Here the second part, that is the sympatholotic, it also having the two parts, symphato and lytic. Symphato, that is the sympathetic system, lytic means breakdown. So the sympathomimetics or sympathomimetics, that means the agonist or which are given to produce the similar kind of effect like adrenaline. So that is the sympathomimetics. Sympatholotics, it is completely opposite. They are the inhibitors, they are the blockers. Okay, so when the sympatholytic drugs are given, they block the adrenergic nervous system. Okay, it may be the alpha blockers or it may be the beta blockers. So these sympathomimetic systems or these receptors, that is the alpha beta receptors, they are present in the heart muscles, in the blood vessels, smooth muscles. Okay, so what happens, they are responsible for the contraction of these heart muscles or the blood vessels. But when we are giving the lytic drugs, that is the inhibitors, this their activity is inhibited. That is their contraction of the heart muscles. Okay, that activity or the smooth muscles, contraction of smooth muscle, that activity is inhibited. So vasodilators and or sympatholytics, these are the two different parts. The vasodilator generally they act directly on the blood vessels, they dilate the blood vessels. Sympatholytically, they are generally the indirect acting, they are responsible to inhibit the activity of adrenaline on alpha receptor and beta receptor, which are related in our syllabus. Now, what are the uses of vasodilators? So the if dilatation of vessels takes place, suppose this is vessels. Okay, so during the atherosclerosis, the formation of plaque or there is a deposition of cholesterol inside the vessel takes place. Okay, so due to this, the blood flowing through this, their force increases, their pressure increases because these plaques which are present in the vessels. In this way, the blood pressure increases, the workload on the heart increases, workload on the heart muscle increases. Okay, it results into the hypertension. But when we are dilating the vessels, now if these vessels, if their dilatation takes place, so space this space increases, and the space, that is the internal diameter of these vessels increases, more amount of blood can be flow through the vessels and more amount of blood can be supplied to the heart. So what happens, heart will get more amount of blood, hence the workload on the heart decreases, blood does not forcefully passes through these vessels, so the blood pressure increases. So these vasodilators ultimately they are responsible to decrease the hypertension, so they act as in the treatment of hypertension. They are also responsible in the treatment of heart failure. They are also given in the vascular diseases, renal diseases, pulmonary hypertension. So such diseases, such symptoms, the vasodilators can be used. Now next part is the classifications of vasodilators and sympatholytics. Is that the vasodilators like hydralazine takes place. Then second one, potassium channel agonist, minoxidil. Then the sympatholytic system in that beta blockers and alpha blockers. Okay, so beta blockers, non-selective, selective beta 1 blockers, selective alpha 1 blockers, mixed alpha and beta blockers. Now you just go through sympatholytic drugs. They are non-selective, selective, mixed. So what is the difference between these selective, non-selective and mixed? Suppose a drug act on beta 1 receptor. It blocks the beta 1 receptor, and it does not act on any alpha receptor or any other beta receptor like beta 2. It acts only on beta 1 receptor. Then you can say that the drug is selective beta 1 blocker. Okay, so the drugs selective beta 1 blockers, they only block the beta 1 receptor. They will not block beta 2 receptor or any other alpha receptor. Okay, now suppose a drug is act or will block beta 1 receptor, and somewhat it having the activity on beta 2 receptor. So they having the activity on beta 1 plus beta 2. So the such drug it's called as non-selective beta blockers. That means they can act on beta 1 as well as the beta 2 receptor. They will not act on alpha receptor. They will act only on the all the beta receptors or one or more than one beta receptor. So they becomes non-selective. Now the third part, that is the mixed alpha beta blockers. So the carvedilol, labetalol, these are the drugs which can act on alpha block, which act as beta blockers. That is alpha blockers and beta blockers. So they are having the activity on both alpha as well as the beta. So they are called as the mixed alpha beta blockers. So in this way the classification of these vasodilators or sympathetic takes place. Vasodilators, hydrolazine, potassium channel agonist, minoxidil. Then these are the sympatholytic drugs. Now we will start with the first drug, that is the hydrolazine. It is a direct vasodilator. Okay, so this is the structure of hydrolazine. So this is the hydrazine part. This is thalazine part. So the hydrolazine is called as 1-hydrazine thalazine. This is thalazine, this is hydrazine, so 1-hydrazine thalazine. It is the first orally active antihypertensive drug which is marketed. Now we'll move to their mechanism of action. So until now the mechanism of action is hydrolazine is not certain that this can act by this mechanism. We cannot say. Sometimes it have act by one mechanism, sometimes it may act by second mechanism. But the dilation of artery or how it dilate the artery, that mechanism is remain uncertain. But it is there are some evidence that it can act by different ways. So one of the way is that they are responsible to inhibit release of calcium, which is induced by the IP3 daxistin, in that IP3 inositol triphosphate. So hydrolazine is responsible to inhibit inositol triphosphate induced release of calcium from intracellular storage. So if the concentration of calcium decreases, then it is difficult for the heart muscles to undergo the contraction process, because for the muscles to be contract it requires the calcium ions, and due to the inhibition of their storage it is difficult to get the calcium ions for the contraction of heart muscles. So it diminishes the contraction as the intracellular calcium ion decreases. So this hydrazine promotes dilatation by opening the calcium activated potassium channel, and also it releases the nitric oxide, which is the directly acting vasodilators. Okay, already we have seen the its mechanism of action, how the nitric oxide works in angina pectoris. So I will not repeat here. You should know only they are responsible to release nitric oxide, which are responsible for the vasodilators. Note that it does not relax venous smooth muscles. Now the second drug, that is the minoxidil, that is the potassium channel agonist. The drug minoxidil is discovered in 1965. This is the structure of minoxidil. Okay, so actually minoxidil having the its usefulness in the treatment of hair loss. Generally the drugs minoxidil is given for the patient to grow the hairs on the bald areas. Okay. It also acts as antihypertensive drug, that is in the treatment of hypertension. Okay. But the minoxidil is not an active drug, it is a prodrug. For the activation of minoxidil, it has to be converted into the active drug, and this active drug is converted with the help of enzyme sulfotransferase. So this sulfotransferase converts the prodrug minoxidil into the minoxidil NO sulfate. So here you are getting NO. Okay. So I will just draw this NO remain as it is, and here the sulfate formation takes place, that is the double bond O, double bond O, and here comes OH. So on this oxygen there is a binding of HSO3 takes place, that is the sulfate group takes place, which is the active form of drug minoxidil. The minoxidil is the prodrug. It undergo sulfation reaction by the sulfotransferase to the active drug, that is the sulfate drug, as minoxidil NO and over sulfate group, so it is called as minoxidil NO sulfate. Okay, so what is the role of this minoxidil, or how it acts as an antihypertensive agent? So it is a potassium channel agonist. Okay, now in case of potassium channel, so potassium is remain inside the cell, so it is the intracellular ions, and outside there is the presence of positive charge species. Okay, so when the potassium channel agonist is given like minoxidil, it opens the potassium channels and efflux of potassium takes place from intracellular into the extracellular. So when efflux takes place outside the cell, there is a positive charge which increases due to the efflux of potassium, and inside potassium is released, so negative charge increases. So in this way, the potential difference between the extracellular part and intracellular part, it is increased, and it is called as hyperpolarization, and this hyperpolarization is responsible for the relaxation of स्मूथ मसल्स. लक्षात आलं. सो आतमध्ये निगेटिव्ह चार्ज असतो, बाहेर मध्ये पॉझिटिव्ह चार्ज असतो, आणि के पोटॅशियम आयन हे इंट्रासेल्युलर आयन्स आहे. सो व्हेन potassium channel agonists are given, it opens potassium channel, so the efflux of potassium takes place outside the cell. So outside the cell, the positive charge increases. As the positive charge goes outside, inside the cell, negative charge increases. So the potential difference increases. It results into the hyperpolarization, and it results into the relaxation of smooth muscles. So relaxation of hard muscles takes place. Okay, so in this way they are useful in the treatment of hypertension. So this is the second drug, minoxidil. Now next part, antiadrenergic drug. So antiadrenergic, they are either alpha blockers or the beta blockers, which are given as a sympatholotic drugs, which are indirectly dilates the vessels. Okay, so alpha blockers, they are also classified into alpha 1, alpha 2, alpha 3, out of which for our syllabus point of view, we should know what is alpha 1 receptor. So the alpha 1 receptor are present in the smooth muscles, liver, and salivary gland. So in salivary gland, they are responsible for the secretion. Here they are responsible for the glycogenolysis. But in case of smooth muscles, they are responsible for the contraction of smooth muscles. So the contraction of blood vessels takes place. So the alpha 1 receptor is responsible for the contraction of blood vessels. लक्षात आलं. And if you have to dilate the blood vessels, what you have to do? You have to give alpha 1 receptor blockers. Okay, got the points. Alpha 1 receptor is present in the smooth muscle, which is responsible for the contraction. So if we are giving the alpha 1 receptor blocker, it will block the alpha 1 receptor. So there is no contraction of smooth muscles, there is no contraction of the blood vessels. So ultimately it will result into the blood dilatation. Now through which mechanism these alpha and beta receptor act. So when adrenaline bind to the beta receptor, they activates adenyl cyclates, which are responsible for the conversion of ATP into the cyclic AMP, and this cyclic AMP activates protein kinase. Protein kinase causes the phosphorylation, and ultimately it will result into the activation of calcium binding proteins, and it will causes the contraction. Similarly, alpha 1 receptor, it also responsible to release protein kinase and calcium. So the kinase is responsible for the phosphorylation. Along with the calcium, they are responsible for the contraction of smooth muscle. So this alpha 1 receptor acts through the phospholipase C enzyme, which is responsible to convert into the IP3 DAX system, that is the inositol triphosphate and diacyl glycerol. Okay, but if you observe alpha 2, here negative, negative, negative is written. That means they are responsible for the inhibition of adenyl cyclase. So there is no formation of cyclic AMP, no formation of protein kinase. So it will causes the dilatation of blood vessels, or it will not causes the contraction. So in case of antihypertensive drug, you can give beta blocker, alpha blocker, and alpha 2 agonist, because this activity is opposite to the activity of beta receptor. So beta receptor causes contraction, alpha 2 receptor causes inhibit the contraction or relaxation. Okay, so if it is relaxing the smooth muscles, we no need to give the antagonist, you can give the alpha 2 agonist. So beta blockers, alpha 1 blockers, or alpha 2 agonist. What is sympatholytic drugs, which decreases the sympathetic activity, which blocks the interaction of norepinephrine or adrenaline agonist with the receptors. So these drugs, they are called as anti-adrenergic drugs, sympatholytic drugs, adrenergic blocking agents, or adrenergic blockers. Now classification into alpha antagonist and beta antagonist. Alpha antagonist, again non-selective. In non-selective, they are again classified into reversible and irreversible. For our point of view, our syllabus point of view, we have selective alpha 1 antagonist, that is the quinazoline ring structure as a lead molecule. So prozosine, terazosin is there for your syllabus. Then selective alpha 2 antagonist is there. Example yohimbine, it is not there for our syllabus. Then beta antagonists, they are classified into selective, non-selective, and mix. So non-selective, selective beta 1 antagonist, and mix alpha beta antagonist. So these two drugs which are mixed, labetalol, carvedilol, there is for our syllabus. This beta antagonist is also there for our syllabus. Non-selective like propranolol, nonolol is there also for our syllabus. Okay, now we move to the next part, beta blockers. So this is the general structure of beta blocker. Now we will move to the sympatholytic drugs. In that beta blockers, so we start with the beta blockers. The drugs which are responsible to block the beta receptor, they are called as the beta blockers. So that is the general structure of beta blockers. Okay, so this AR indicates aryl group. This is oxy 1, 2, and 3. So propyl with hydroxypropanol, and this is amine substitution. So amine. So this beta antagonist is called as aryl oxypropanol amine. Okay, so they consist of, in case of SAR, if we have to go through, this is the general structure for the beta antagonist. So secondary amine, this is secondary amine, NHR. If R is H, that is primary amine, it will decreases the activity, but NHR, it is the secondary amine, it will require for the optimum activity. Then at beta position, hydroxy group is there. So this beta hydroxy group, it must be in S configuration. So we have R configuration and S, out of which this hydroxy group must be in the S configuration. Then OCH2 group has been incorporated between aromatic ring and ethyl amino side chain. Okay, so this OCH2 group. Okay, and this is CH2 CH2. This is the ethyl. This is amino. So OCH2 group must be present between ethyl amino side chain and aromatic group. So such case is present, it gives more potent beta blocker. That means this aryloxypropanolamine is the potent beta blocker. Now this aromatic ring or the nature of aromatic ring, it is responsible for the ADME, pharmacokinetics, absorption, distribution, metabolism and elimination. So if at the para position of this aromatic ring, suppose this is the aromatic ring, at the para position of the aromatic ring there may be presence of substitution, it will give the proper activity. But at this is ortho, this is meta. If any substitution is there on meta position, it will decreases the beta 1 selectivity. So M position must be the empty so that beta A selectivity will be more. Now if the given molecule is lipophilic in nature, so as we know, if it is lipophilic, it can cross the blood-brain barrier. So it will produces the CNS side effects. As it can crosses the blood-brain barrier, it will enters into the brain CNS system, and there is also some adrenergic receptors are present. So adrenergic can receptor, so it can block that receptor, and they are responsible to produce the sedative effect or the CNS side effects. Okay, and if hydrophilic drug, they cannot cross the BBB, blood-brain barrier, so it will not produce any side effects. As well as such drugs, that is this neurotransmitter, they are having the structural similarities with other neurotransmitter which act on the CNS, so it will produces the sedative like side effect. So these are some examples of beta antagonist: propranolol, pindolol, nadolol. So these are some examples of beta antagonists of first generation.